Let's solve this LeetCode problem. You're given an integer array and you have to find the longest square streak. So a square streak is a sequence whose length is at least 2, and if we sort this sequence, every number in increasing order, every number will be the square of the previous value. For example, we're given this nums here. We have 2, 4, 16. So you have 4 here, 16 here, and 2 here, right? So this is a square streak, and it is the longest one. So when you sort it, you have 2, 4, 16. 4 is the square of 2, and 16 is the square of 4. So we have to find the longest one. For example, there is no one here. So there's no square streak in this array. Now, how we can think of this problem? First of all, we can sort the values in increasing order. Since when you find, for example, 4, 16, 2, now a square streak is, this sequence has to be sorted after we obtain it. So we have 2, 4, 16. Now then you can see that 4 is the square of 2 and 16 is the square of 4. So what we can do is to first sort this element. So let's sort them. We have 2, 3, 4, 6, 16, and 8. So one thing to notice here, if we have like 2, 4, 16, let's say this is your square streak. Now let's look at 16. When you reach a number, let's say this is 16 for now. You can think of, okay, let's say this 16 is the last element of such a sequence. If it's the last element, then the previous element is its square root, right? So if we have 16, the previous element has to be 4. So if we can know the length of the sequence that ends with 4, then we can find the length of the sequence that ends with 16. It's just one more element. So we just add +1. So that's where comes the DP idea. So you have a way to transition from a smaller instance of the problem to a larger one. So knowing the length of the sequence that ends with 4 helps us to find the length of a sequence that ends with 16. So then we say dp16, or first of all, the dpi would mean the length of sequence ending with I, the number I. So dp16 is the length of the sequence that ends with 16. It would equal to the dp of the square root of 16, which is 4, plus 1. If such a sequence does not exist, such that, for example, if we take 8, there cannot be a sequence that ends with 8. There can only be itself 8. So this is, since we know that the answer has to be, the length of the sequence has to be more than 1, it has to be at least 2. So this is not valid. But yet still we can count it as a sequence whose length is 1. So for example, for dp8, it would be, so we don't have this dp transition here. For dp8, the previous value would not exist, so it would be just 1. So this is the transition. So when we're at 2, for example, let's just fill the dp array. When we're at 2, the 2 does not have a previous value for a sequence, because nothing squared gives us 2. So the dp of 2 is just 1. dp of 3 is the same. So the dp of 3 is just 1. So we have dp of 4. So the dp of 4, so ending with 4. So 4 has 2 before it. So what is the length of 2? We already have it. So the dp of 4 is dp of 2 plus 1, which is 2. So when we're at 6, 6 does not have anything before. So dp of 6 is just going to be 1. And then filling the other values, dp of 16. So now we have for dp of 16, we have 4. What is the length of this sequence? So we have it's the sequence ending with 4. We have it in dp4 array, which is 2. It's going to be dp4 plus 1. So it is 3. For 8, again, dp of 8 is going to be 1 because we don't have nothing before. That could be squared to have 8. That's going to be 1. So after that, we'll find the maximum. So this just means that every dp entry means the length of length of a sequence that ends with I. For example, the length of the sequence ending with I is 1. Ending with 2 is 1. Ending with 3, it's 1. Ending with 4, it's 2. It's 2 and 4. So we find the largest value. It's going to be 3. And in case if there is no no sequence, we'll have the maximum value either 0, we'll have the maximum value as 1, or yeah, we'll have 1. So if that is the case, we'll just return -1 because the length has to be at least 2. So that's the whole idea of this problem. So the reason we sort this array at first is because when you get a value, a sequence for 16 and 2, you'll sort it anyway. So sorting does not affect the process. So we have 4, 16, and 2, but it's actually 2, 4, and 16 that we want to check. So we just want to know if there is such a sequence in the array. Does not matter the order. The order does not matter here. Like you might have 4, 2, 6, 16, 16, 2, 4. They all are the same. So it's equal to 2, 4, 16. So yeah, this is the idea. And while I sort this in increasing order, you can do this in decreasing order and thinking the other way around. So I said 2, 4, 16. I said let's think the current value as the end of a sequence. But you could have done something else. You could say 2, 4, 16. Let's think the current value as the beginning of a sequence. So instead of dpi, so instead the dpi in this case would mean that the length of sequence starting with the value I, starting with 2. So then in this case, in order to know that the length of the sequence that starting with 2, you would need to know the length of the sequence starting with 4, which would be this one here, right? So dp of 2 will be dp of 4 plus 1. So you see you have to process the larger values first. So it's, in this case, you would sort the array in decreasing order. You would have like 16, 4, 2 in this way. You would first find the length of the sequence that start with 16, it's 1. The length of the sequence that starts with 4, if it's start with 4, then the next value has to be 16. And we have the length of the 16, the length of the sequence starting with 16 is the dp 16 plus 1, which would be 2, and for the 2 we have this one here, the DP42. You can do that way. I guess this would have been easier. I'll tell you why. Because, okay, let's just look at the code. So I have a DP array n. N is the maximum at most 10 to the, what was it? 10 to the 5, 10 to the 5th. And yeah, I sorted in increasing order. And then I get x. And the DP nums I will always be 1, at least 1. This does not really matter if we have like 2, 3, 2, 3, 5. For all of these values, we have DP2 is going to be 1, DP3 will be 1, and DP5 will be 1. So when we find the maximum, it's going to be 1. So we'll just return -1. So DP nums I just put 1. And then I check if there is an x. So basically, this one is this one here. So every sequence, every DPI has always 1. Has always 1. It doesn't matter. It does not really matter if DP at the transition exists or not. So we'll go back. So check if it actually has the square root, the square. So x times x is actually equal to the nums I. Then yes, it exists. For example, if we find for 8, it's going to be something like 2 point something, and we scale it down to an integer. So it's going to be 2. So 2 times 2 will not be equal to 8. So for 8, a square does not exist. A number does not exist. So we check that here, and then we have DP nums I will be plus the DP of x. At the end, we find the maximum, and if the maximum is smaller than or equal to 1, we return -1. It actually cannot be smaller than 1, but just for completeness, the length of the sequence, as it says here, has to be at least 2. So if it's less than 2, if it's 1 or 0, so we just return -1. Otherwise, we will return the maximum. I just want to run this just to show you. I already solved that. Yes, it works. This is a really fun problem, and you can look at it from a different angle. Just like I said, you can sort it in decreasing order, and you can look at the other way around. So essentially what we did, let's just recap. Without a sequence, okay, we said, okay, if I have such a sequence in the array, let's think about the last value of this array. So what we have remaining values, so let's just say this part here, right? So the last value, whatever this value is, this one here, if we can find a value that ends with the square root of this value. So basically, if for given a value x, there exists y, such that y times y, or y squared, is equal x. So we need to find the length of the sequence that ending with y. So this is going to be, so say this is x, it's a little bit messy, and this has to be y. So we need to find the length of this sequence. So that's why we process it. So we first find this one. So to find this one, then we first find this one. So for example, for y, there exists a, let's say, m, such that m squared is y. So we find, so here would be m. So we find this sequence here, and then we find this sequence here, and like that. So for this reason, we start from the smaller values and we grow to larger values, so with larger sequences. So that's why we sorted it in You can do it in decreasing order or increasing order. The other perspective is, if you have this value here, you can say, okay, this is the beginning of a sequence. This number here, let's say it was x, so then we have to find y, such that y squared is x. So let's find the length of this sequence. So if we store this dpy as dpy, then the dpx would be dpy plus 1. So that would be all. So thank you for watching, and I hope you learned something. See you in the next videos.